Thank you so much for that intro. That beautiful music as I just come waltzing in. Jeffrey B is an episode of The Locks. And in this episode, we're going to be talking about a couple of different things related to the live on experience, the LOX. The first thing we're going to be looking at is some of the considerations, some of the concerns that people may have regarding cryonics and then ultimate reanimation, right? We're going to talk about some of the concerns there, and we're going to go into discussion about memory retrieval and imprinting memory on the newly reactivated mind or brain. So, the first thing, let's just jump in then and talk about some of these concerns. Well, the first thing we've got to think about is okay, as we know, as I've talked about in previous episodes of the logs, we have these options of neurocriopreservation, which is just preserving the head and or brain, and then you've got whole body. Okay. So if you do decide to preserve the brain in a cryoprotectant, um, we're going to need some stimulation of this brain every once in a while so that the memories, the data within the brain is going to be retrievable and viable. Think about it like a hard drive on a computer, on one of those big desktop, the towers, right? I had recently, I went back to visit at mom's, and there are two computers downstairs, towers, desktop PCs, and she never turns them on. Um, if you don't turn a computer on for a while, there's a chance that the data can get corrupted just because it doesn't have any flow of data or electricity through it, right? Just the fact it's not on and it's off could actually crash the hard drive and make it irreparable. Okay. And you can think of the same thing with the brain. If you don't stimulate it somehow and get some juices flowing through it, get the memories and the neural circuitry flowing every once in a while, then the data within it, like the hard drive, the data could be irretrievable if you don't keep it stimulated every once in a while. So this is something that needs to really be considered when we've got these brains in a vitrified state, suspended state, or cryoprotected state, right, on ice, preserved. Another thing to look about, to consider and look at here is the connectome, the map of the actual circuitry in the brain, the pathways in the brain, the highways and byways, right? That's tailored. That's a tailored experience. So we can't really get a generalized template for one mind and say that's going to fit all because of the neuroplasticity of the brain. So we can map the brain, yes, in a connectome, but it's going to need to be tailored to each individual person. And we could use that template for that given brain, that given mind to actually reproduce at a later time, right? Now, another thing to look at is some of these preservation methods are using aldehyde. Well, that's toxic to human tissue. Okay. So that's going to fix the tissue and fix the cells and everything in place. So it's viewable, maybe scannable, but retrievable. Now that I can't say. And is it going to be rebootable or reactivatable? Now that's a probably no because the aldehyde is going to actually be cytotoxic. Okay. And so we're going to need a non toxic cryoprotectant to have successful reanimation ultimately if we're bringing the brain back as an actual physical brain, a physical organ again. And there are a few different methods for this. We have different amino acids that may be used here. So you've got your non-toxic cryoprotectants as being the following. You've got your NADES, or your NADES, if you will. These are a natural deep eutectic system. And that's an alternative to your conventional cryoprotectants. These are made up of natural primary metabolites like amino acids, sugars, sugar alcohols, and they're usually found in things like the ground squirrel in the Arctic ground squirrel. They have these in their bodies and their CSF, cerebral spinal fluid, that's going to allow for a lower temperature without causing damage to the tissue. You've also got things like the natural amino acids I mentioned, your L-proline, um, plants, yeast, flies, rams, humans even have this to help with the lower temperatures, the hypothermic conditions. You've got your trehalose, okay, that's a natural disaccharide or sugar that can be developed and delivered into cells using ultrasound and micro bubbles. This preserves cell viability, membrane integrity, et cetera, et cetera. Okay. Other cryon protectants include DMSO, which I would not recommend. That's going to have some toxicity to it, and ethylene glycol and glycerol. Okay. So the ethylene glycol, that's antifreeze for anybody. That's 1,2-ethane diol, right? For you organic chemistry guys out there, girls, guys, trans, and all that fun stuff. It's 1,2-ethane diol, ethylene glycol, antifreeze. Um, if ingested, the metabolites of ethylene glycol or antifreeze can be cytotoxic, toxic to the tissue. Now, if the actual brain is infused with this and there's no actual breakdown into the metabolites of ethylene glycol, then you may not have an issue with this. So there are some that are using this as a common cryoprotectant. All right. Um, There is a nonprofit, by the way. We may get into this later. There's a nonprofit, a nice alternative to Alcor. Alcor being the very quite expensive um, cryopreservation life extension company based out of Scottsdale, Arizona. Then you've got another one up in Oregon that actually is nonprofit, and they're only going to charge, I think, about $15,000 for a whole head cryopreservation. And I think they even do the brain, just the brain refrigerated in some kind, maybe aldehyde or something for free. Of course, that you're going to be basically donating your brain to science in that regard because you're probably not going to be able to be brought back in that capacity because the aldehyde is going to destroy the brain tissue. Okay. But it might still be scannable and be able to actually store the data from the brain into another form, download maybe a digital afterlife, something of that nature. These are things to think about. And of course, we all know what we can see coming up here. You see this. What's one of the big fears? Obviously, we might think, well, what if my relative comes back or I come back in a form that's not recognizable by me or is alien to me? Like, Futurama did it great when they said, "Oh my gosh, look at this! This is the head I know of Nixon, but as far as the body goes, no, the body's gone." Boy, Futurama's ahead of its time. And there's a great caption that goes with this that says, "A head in the polls, and no body can run twice," or something, can be elected twice. So they just puns all over the place, ahead of its time. Matt Groening, and The Simpsons and all that stuff. Um, so yeah, we would want to address that concern, and we'd want to reproduce uh, the form as much as in the way we remembered it as possible, so that we can feel connected again and feel okay about navigating through and convincing people to participate in cryopreservation. So they don't feel like, because they've got all these concerns, what if I come back and I'm just a guinea pig, or I'm stuck in some computer and I can't get out of my mind. I'm aware of it, but I don't want to be aware. I want to be offline. I don't want to exist anymore. Yeah, these are real concerns. People will have to address those as time goes on, and we get people to be more willing to opt out of the traditional clinical death ideology, dogma, really, and away from cremation, away from burial and all that other stuff, and into preserving the DNA, preserving the brain and the memories so they can be rebooted later, reactivated, restored. Um, so those are all concerns we've got to really, look at. But now we want to get into this. I want to shift focus now. So those are some things to consider. Wrap your head around, try to think about when it comes to cryonics and life extension and the logs, live on experience. Now, we want to talk about memories here. Switch focus just for a moment. You know, one of the things we want to be able to do, obviously, is to, once we have the data, right? Once we have the brain, we want to know how can we actually reactivate the memory system once the brain does come back online, or the mind is transplanted into a digital afterlife. Like I write about, the Lox is actually the name of the digital afterlife platform in my novel True Five and the Scumbots. And you can get a copy from me if you're interested sometime. Um, you know, so we've got some interesting species, some interesting cases here, and I'm going to put them up on the screen there. What you can see is you see quite a few different models here. We've got your holometabolous insects, your planarian flatworms. We've even got your Arctic ground squirrel. Three main models here. And in each of these, there are changes that take place in the central nervous system. In one of these, the planarian in the middle there, it actually, you can completely lop off the head, decapitate this thing, and it can regenerate a whole new brain with the memories imprinted onto this newly formed brain. Okay, that's crazy, right? That's amazing. In things like the holometabolous insects, there's a pruning of the neurons, and even basically breaking down of the old um, primitive mind or primitive brain into a completely new uh, system in the adult. So it's like night and day between the larva and the actual adult of some of these holometabolous insects. And then in the Arctic ground squirrel, we've got things like, after a very long period of hibernation, uh, there's a restoration of morphology in the brain volume, coming back to normal, kin recognition, identification of familiar versus non-familiar individuals. And all this stuff comes back within like a couple of hours of coming out of hibernation, of arousal. All right. So what does this really all mean? What's this come down to? Basically, what it comes down to is that memories could very well be stored as genetic material in the form of RNA, or in a particulate nature, perhaps even outside the central nervous system, okay, or the neural bundle or whatever. Um, like in the planarian, the memory may be stored outside the brain, and it can be imprinted on the nascent or the newly formed, newly regenerated brain after or during regeneration. So, this is something to really think about. That's why they talk about, you know, if you look at the options for whole body versus neuropreservation in at Alcor, they go into it. It's a great pamphlet that talks about the advantages of both, right? And one of the advantages of whole body, which is way more expensive, obviously. And by the way, the Oregon Brain Project (OBP) does not have any whole body cryopreservation option. That's where Alcor trumps that. Obviously, they have the leg up on that. Ha, no pun intended. You got your leg in there, still. It's possible that the body may actually store memories. Okay. It could be the RNA of the body may house, it may require the body, the positioning, or things like that, so that the brain would know how to regenerate in that regard. So there may be some RNA from the body that may be required. We don't really know exactly, but there's a possibility that we could move away from the old conservative traditional idea, which is known as the synaptic plasticity hypothesis. In other words, in this hypothesis, all the memory system is set up in synaptic connections. Okay. And that's the only way memories can exist is within those synaptic connections. Um, Moving away from that conservative idea would bring us into this whole possibility that memories could be stored outside, first of all, outside of synaptic pathways or channels or connections, and maybe even outside the nervous system or the brain or the neural cluster itself, depending on what kind of organism we're talking about. And this really could bring us to a lot of amazing paths forward, because if you might have someone, let's look at the ramification or consequence or possible uh, way of looking at that further. If you have someone whose central nervous system has been destroyed by cremation, but you've still got some of their genetic material, it could be likely, maybe in humans, we don't know. It could be that the memory could be stored in the RNA or some other facet of the remains of that individual that could actually still contain the data for the memories and could be imprinted on a newly regenerated brain, whether that's a physical brain or even somehow uploaded, and downloaded into a digital afterlife where the mind may get transplanted, as I mentioned before, the e-consciousness, right? So we want to keep our minds open, no pun intended, to the possibility that memories may be stored in other ways rather than the synaptic plasticity model. Okay. So this is really exciting stuff, and using these planarians, using the Arctic ground squirrel and the holometabolous insects, we can see that we may be able to use these to understand how to regenerate the brain after. Because, like I said, the main goal here is we know we're going to be able to get a new brain back, but how do we reactivate or restore the memory system so that we can basically recover who you were or who I am, who I was? I want to bring Jeff back as close to the previous form as he was as possible, or my mom, or your dog, or whatever, right? Or your cats, okay? You want to bring them back as close as possible. So we got to understand how to um, retrieve the data and how to restore, how to reactivate the memory system. And so we may have a lead here that we can use uh, wherever the memories are stored. What form are they stored in? Okay, that's all the time we have today. And until next time, live on.